Hi everyone, and welcome back to our next lesson of statistics. And in this lesson we will look at the variance and standard deviation of data. Now what are they? Well, these measures help us to find the average deviation from the mean. In other words, the spread around the mean. So if we calculated the average of data, we want to know all the other numbers. What is the average difference that they have from our calculated average of all the data? And I'll show you in a few minutes what that means. Well, the standard deviation is the square root of the variance. Now, our symbol that we use for the standard deviation is the Greek symbol that looks like this, and it is called sigma. Now, basically, if we want the standard deviation and we have the variance, we simply square root the variance and we will have our standard deviation. Now, this is a way better measurement to find the average deviation from the mean, so we'll focus on this one. But I just want you to remember that if they give you the variance and you need the standard deviation, you just square root the variance. So basically, another way that they sometimes write the standard deviation is just an S. So the variance will be S squared. In other words, sigma squared will be the variance. Now, let us look at what the standard deviation tells us. Now, when we have a normal distribution like this bell curve, in other words, our data is symmetrical. And what does symmetrical data mean? It means that our average is exactly the same as our median. And we looked at that in our previous lesson, okay? So two things are now important. When we have a normal distribution and we know what our standard deviation is, and we also can calculate our average, we can simply find very important information. So let us see what all of this actually means. Now, our average is right here in the middle, okay? Now, if we subtract our standard deviation, and we are going to make our standard deviation just sigma, so we're not working with values, but it works the same. So if I take the average and I subtract our standard deviation, and I'll show you here in red. So we are going to end up somewhere here on our bell curve, which is going to be our average minus our standard deviation. Now, if we subtract it, we also want to add it to the other side. And that means if we want to end up right there, we are going to have to take our average and we add our standard deviation. Now, this basically means that we are within one standard deviation from the mean, okay? One standard deviation to both sides, and we again say we are within one standard deviation from the mean, okay? So this section here is within one standard deviation. Now, when this is a normal distribution, we actually know very important information now, that 68% of all the values in our data sample lie within one standard deviation. In other words, 68% of our numbers will fall within that range there, okay? So I'll show you again in red. So from this point here, we calculate from there to there as well as to there. So in this entire section, we will find 68% of our values, and I'll write it here, 68%. So if we had 100 numbers in our data set, we will find 68 numbers in this range here, okay? So what if we are within two standard deviations? And I'll do this part in blue. So we'll end up somewhere here on these two blue lines, okay? Can you see I just drew them in there as well as there? And to get there, we had to take our average and we had to subtract two standard deviations. To get to the other one on this side, we also had to take our average and we had to add two standard deviations. Now, what do we learn if this is a normal distribution and we are within two standard deviations? In other words, we are from this point here all the way to that point there, okay? So that basically means that 95% of the values in our data set lie within 2 standard deviations. So that means if we had 100 numbers in our data sample, that means 95 of those numbers will fall within this blue range here, from there all the way to there. Okay, and we call this within 2 standard deviations from the mean. Now, if 95% of our numbers fall in that range, how many fall on the outside? 5%. But there's two sides, right? That means 2,5% is on that side and 2,5% on that side. Okay, got it? Now, how about the last one? If we want to end up on these black lines that I draw in there and on the other side there, that means we had to take our average and we had to subtract 3 standard deviations. And to get to the one on this side, I had to take the average and I had to add 3 standard deviations. Now, to go from that black line there all the way to there in that range, we will find actually 99.7% of the values within 3 standard deviations. So that means 99.7% of our numbers in our data sample fall within 1, 2, 3 standard deviations from the mean. Okay, from that black line all the way to there. And I'll show you quickly. So from that point all the way to this one right there, we will find 99.7% of our data. And again, in this red one, 68% of our data, and this blue one, and I'm just going to write that in as well, 95% of our values fall within 2 standard deviations. Got it? So now we know how many of our numbers we can find within 1 standard deviation, how many numbers we can find within 2 standard deviations, and how many of our numbers we can find within 3 standard deviations. And since you know that, you also know how many fall on the outside. So if 68% of our values fall within 1 standard deviation, that means 32% will fall on the outsides. So that means on that side we will have 16% and on that side 16%. Now what if we are within 2 standard deviations? Well, 95% of our numbers fall within 2 standard deviations. So it means 2.5% are left on the outside of 2 standard deviations and another 2.5% on the outside of this side of our normal distribution. Got it? Okay, great. So I hope you understand the concept, because now we are going to work with real numbers and then we're going to use it to calculate other important things. So let's go and try some examples. Now we are going to look at an example and we are going to learn how to calculate the standard deviation, and then also we are going to see how we can apply it in practice. So here is an example. The mass of 10 grade 9 learners were taken and these were their masses. Okay, so 40 kilograms all the way to 60 kilograms. Now we want to calculate the mean, median and mode, and this is a bit of revision on our old statistics, right? So if you want to calculate the mean, that means it's basically this x with the little line at the top. So what we want to do is we want to add up all these values and then divide it by 10 because there's 10 numbers, right? Okay, and we get an answer of 500, which you can try to get at home by adding up all those numbers. And then we divide it by 10 because there's 10 numbers. And then we basically get an answer of 50. Okay, great. Now we want to calculate the median. Now you saw from before that it's important to calculate the median if we want to know the 5-point summary and draw up a whisker diagram, and the calculation of the median changes if we have an even amount of data and an uneven amount. Now in this case there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers because there's 10 grade 9 learners, and because there's 10 numbers it's an even amount. So what we do is we take that 10, we divide it by 2, we get an answer of 5. But for any even amount of data, we have 2 values in the middle. So it will always be the 5th and then the next one, which will be our 6th value, right? So let's go find it. 1, 2, 3, 4, 5, that is 48. and we look at the sixth one as well, which is 50. So then we basically, to calculate Q2, which is our median, we're going to take the 48, we're going to add the 50, and then we're going to divide it by 2, which gives us an answer of 49. Okay, brilliant. Now to calculate the mode, that is also quite easy. The mode will simply be the values that exist the most, okay? So in this case, our mode will be 45 and 56 because they exist, both of them exist 2 times. So I'll write that in, that will be 45 and 56. Okay, brilliant. Now, we want to calculate the standard deviation. Now, pay careful attention to this part because it is quite a process. But I'm going to teach you a way so that you don't waste any time. Now, to calculate the standard deviation, we have to calculate the average. And then this average, we have to take it and we have to minus each one of these data numbers each time. So it will be 50 minus 40, we'll get an answer of 10. We write the answer 10. Then we go 50 minus 42, we get an answer of 8. We write the answer 8. Then we do the same for all of these numbers. Then the answers we got, we have to square each answer. Then we have to add up all those values, and then we will get the variance. And to get the standard deviation, we have to square root the variance. So basically that is quite a process, and you can imagine how bad it will be if we have 100 of these numbers. So I'm going to show you how to do it on the calculator, and yes, you are allowed to use this method in the exams because it saves you a lot of time. So let's have a look at how we do it on our calculator. So here's my calculator, and please follow carefully. And here we go. So I press the mode button, then I press 2, okay? And I'll quickly pause that again. Let's go back a little bit. Now, there we go. And we press the mode button, then we press 2 to enter the stat part of our calculator, okay? So once we enter the stat part, there's the 2, you can see there's a whole lot of things that they're talking about here. Now we want to go into the 1 minus the variance there, okay? So we are going to press 1, and then it's going to open up a small little table there. Now we're going to enter all our x values. So we start with 40 and then we press equal. 42, press equal. 45, press equal. 45 again, which is our 4th number, and there we go. And then 48 equal. 50 equal. And 56, there we go. And another 56. And then 58, there we go, and our last number, which is 60. Okay, brilliant. And once we do that, we just press our off button there, and then we press shift, and we go to number 1 so that we activate that stat. Now we want to go to variance, which is number 4, and I'll pause there. Which one is the sigma? And now you can even see if you press number 2, you are going to have the average. If you press N, you will know how many numbers you entered, which is 10. If you enter that sigma notation there, what do you think you are going to get? Well, sigma is our standard deviation, so you will get the standard deviation. So I'm going to press 3. There we go. And press equal. And boom, there is our standard deviation. And if we round it off to 2 decimals, it's 6,74. So now we know that our standard deviation, which is sigma, is equal to 6,74. There we go. And that's all there is to it. So if you want to enter other data now, let's say the next example, and you want to enter all of these data into a new example, look what you have to do first. You first have to go and clear your calculator's memory, and I'll show you how to do that as well. So you simply press shift, you go to number 9, at the top there's this CLR, which means clear. You say all and press equal, and then your memory is cleared. As easy as that. Okay, great. Now let's put that away, and then we go and have a look at our last question. Now they want to know How many learners have a mass that is within 1 standard deviation from the mean? Okay, so we don't know if this is a normal distribution, but we're going to use that kind of knowledge. They don't want to know how many learners as a percentage. They really want to know how many learners have a mass that is within 1 standard deviation. Now let me quickly show you what that means, and I'll draw in a bell curve. I'll try my best to do this as neatly as possible. So if I draw in a bell curve like this, there we go, and then I also draw this line here at the bottom, maybe not that straight, but there we go. And now we know that our average will be right here in the middle, and we know that this is 50, right? Now they are talking about 1 standard deviation. Now our sigma or standard deviation is 6,74. So now we take 50 and we minus 6,74. And if you do that, 50 minus 6,74, you will get an answer of 43,26. So that means 1 standard deviation lower there, we end up with 43,26. And if we add 6,74, we're going to end up with 56,74. Okay, so that basically means that we want to go and look how many learners fall in those masses from 43,26 all the way to 56,74. So it has to be bigger than 43,26. So we're looking at anything from 44 all the way to 56. Okay, so let's go and count quickly. 40 is lower, 42 is lower than 43, so no, they don't fall in that range. 45 is bigger than 43, and it's smaller than 56. So 45, that's 1, 2, 48 falls in that range, that's 3, 50 is 4, and we have 5, 6, and that is all there is to it. So, because 58 is outside this range, so we basically have 1, 2, 3, 4, 5, 6 learners that fall within 1 standard deviation of the mean. Now, that was the explanation. How are we going to write it? So what we need to do is we need to first find our 1 standard deviation lower and our 1 standard deviation higher. And you actually have to show that calculation. So we are going to take 50 and we are going to minus the standard deviation 6,74, and that gives us an answer of 43,26. Then we're going to take 50 and we're going to add 6,74, and that's going to give us an answer of 56,74. And now we basically have to go and look how many of these values here fall within that range, and we saw that there were 6 values, so 6 is the answer. So 6 learners fall within 1 standard deviation. And if we want to know how many fall on the outside, well, basically that will be 1, 2, and then we go 3, 4 fall on the outside. Got it? Okay, brilliant. Now, if they asked what's the percentage of learners that fall within 1 standard deviation, we could have said 68%. Okay, but they didn't. They asked how many learners. Now, let's go and look at another example. Now, here is another example. You can try it first at home and then see if you can get it right. So, a few more examples. The time taken in minutes by a group of grade 12 learners to complete a 5-kilometer race is given below. So, some of them take 18 minutes, 21 minutes, 16 minutes, 24 minutes, all the way to 23 minutes. Okay, now we want to calculate the average time it took to complete the race. Now, to get the average, that is quite easy. We simply add all those values. We get an answer of 220 if we add all of them. And then how many learners are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are going to divide it with 10, and our answer is 22. Okay, great. So that is our answer, and now we can continue on to the next question. Calculate the standard deviation of the time required for the race to be completed. Now, to calculate the standard deviation, again, we are going to use our calculator, and I'll show you how to do that. So again, there's the calculator, so please follow. We press the mode button and then 2 to activate the stat, then 1 because we want 1 minus the variance, and then we enter all the data. So 18 equal 21 equal 16, press the equal button, 24, press the equal button, 28. That's our next one. Then 20 again, and 22, and again 29, and 19, and the last one is 23. So there we go, and then press equal, and then we go and press the off button, then shift, and then we go to the one that says stat. And there we go, we want the variance and we want sigma because we want the standard deviation. And then you press equal and there we go. So now we know what the standard deviation is. Our sigma is equal to 3,95 when we round it off to 2 decimals. We always look, if we want to round it off to 2 decimals, we go to the third one, it's bigger than 4. So this will become a 5. Okay, brilliant. And remember to clear your memory once you are done if there's any other sums that you want to do with statistics. So here we go. How many runners completed the race within 1 standard deviation of the mean? So again, what we need to do is we have to take our average and then we are going to minus the standard deviation. So 22 minus 3,95, and then once we calculate that, we write that answer down because it's so important, and that will be 18,05. Then we take the 22 and we plus 3,95, and that basically gives us 25,95. So these are the two values, so that gives us the range of within 1 standard deviation from the mean. And now we want to see how many of these values fall within that range. So we're looking at values greater than 18,05 and values smaller than 25,95. Okay, so basically bigger than 18, that's 21, that is 1. 16 is smaller. 24 is in that range, so that's 2. 28 is bigger than that range. 20 falls within that range, that's 3. 22 falls within that range, that is 4. 29 is on the outside. 19 falls within that range, that's 5. And 23 falls in that range, that is 6. Okay, so basically we know that 6 runners completed the race within 1 standard deviation of the mean. And that's all there is to it. Easy, right? So from this information, we already know that 6 runners fall within 1 standard deviation, and therefore we can say that 4 runners fall on the outside of these values. So if 4 of them fall on the outside of these values, we know 2 will be higher than this and the other 2 will be lower than that time. And that's how easy it is. What if they ask us, we have to calculate how many runners completed the race within 2 standard deviations of the mean? That basically means we're just going to subtract that value twice. We're going to add that value twice. We get a new range, and then we go and see how many of the learners fall in that new range. And that is really that easy. So let's go and try one other example so that you can see if you clearly understand what the standard deviation means. Now in this example, we have grade 12 learners who wrote an exam and the average mark was 58%. So we can say that that is our average, and then the standard deviation was also given to us, which is 12. So we can write there that that is our sigma. 120 learners wrote the test and the distribution is normal. So that's quite important information. Because the distribution is normal, we know it is symmetrical. Therefore, we have this important information that we learned earlier on in the video. That 68% of the learners, because we're busy with learners, right? So 68% of them fall within 1 standard deviation. We know that 95% of the learners fall within 2 standard deviations, and then we also know the last one where we can say 99.7% of the learners fall within 3 standard deviations. Now, what we want to know is how many learners would you expect to achieve between 46% and 70%. So, these values are quite important because let's see where they came from. We simply take our average, which is 58, and we subtract our standard deviation, and then we get 46. If we take 58 and we plus 12, we get an answer of 70. Okay, so basically those two percentages are within one standard deviation from our mean. So that is our range. And what they want to know is how many learners would you expect to achieve between 46 and 70%. Now, in that range, we know that 68% of the learners will be within one standard deviation. So to calculate how many learners fall within one standard deviation, we simply take the 68% and we're going to work with 0.68. We simply multiply it with 120, and then if we do that calculation, if I'm right, it will be 181 something. So times it, yes, it's 81.6, and we can round it off. So we can say 82 learners fall within 46 and 70%. Now, let me quickly show you here with the normal distribution what this means. They say that our average here is 58%. Okay, and I'll write that in blue as well. So that is 58%. Okay, and they also told us that it's a normal distribution. Now they give us a standard deviation of 12. So if we get to this red marker here, we actually took 58 minus 12 and then we got 46, and I'll write that in. So this 46 is within one standard deviation lower than our mean, and then we also have the one that is above the mean, right? And 58 plus 12, that gives us 70. So now we know, since this is a normal distribution, within this range here, from there all the way to there, we will have 68% of our numbers. Now, that means 68% of our learners fall within that range of 46% to 70%. So we simply take 0.68 times 120 learners, and we got 82 learners that fall within that range. So there's 82 learners, and if we take their exam percentages, so there's 82 marks or 82 learners that whose marks fall within 46% and 70%. Now, we want to know the next one. How many of the learners are expected to achieve over 82%? Now, that 82 came from the following. We took our average and we added a 12 and we added a 12 again, and then we got 82%. Okay? Now, we added the deviation 2 times. So that's 2 standard deviations bigger than 58. So basically, I'll do this in our blue pen. So we are right here, and that's where the 82 comes from, because the standard deviation is 12. So plus 12 is 70, plus 12 again is 82. Okay, so let's subtract it, and then we get 34. So there's 34. So from this point here all the way to that point there, we will find 95% of our learners, okay? Or 95% of the marks. And that basically means that on the outside of these two, 5% remains. But we don't want to know how many got below 34. So if 5% is this part, including that part, and we just want to know the top part, it's half of 5%, right? So basically, and I'll show you here in my black pen, so this part here is going to be 2.5%, and that part there all the way will also be 2.5, because together all of this must give us 100. So now we just want to know how many learners got above 82. So then we take 2.5%, which fall above the 82, and we simply take 0.025 times 120 learners, because in our sample we will have 120 percentages, because there's 120 learners who wrote it, right? So 0.025 times 120, and we get an answer of 3. So 3 learners got above 82%. Got it? Now we need to calculate how many learners would you expect to achieve under 46%? Now we know that 46% falls within one standard deviation from the mean, okay, lower. So within 46 to 70 we find 68% of the learners. So again, I'll quickly show you in my black pen there that from this point onwards all the way to the end, and on the other side as well all the way to the end, it has to make up 100%. So if 68% of the students' marks fall within 46 to 70, that means 32% fall on the outside. So that means that 16% will be here and the 16% will be on the outside, right? And now we want to know how many of the learners got under 46% for their test. So that means 16% of the learners got under 46. But we don't want to know in percentage, we want to know the exact amount of learners' marks that's below 46. So then we take 16%, which is 0,16. We times it with 120, and then we basically get an answer of 19,2. So that means 19 learners got below 46%. And that is all there is to it. Okay, so I hope you really understand how the standard deviation works and how we can use it, especially when we have a normal distribution. Keep practicing and see you next time. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.